So we're going to continue on lesson 2, and now we're going to speak about we're going to write for polarity of covalent bonds. Polarity of covalent bonds. So the covalent bonds, in the covalent bond there is sharing of electrons. Okay, in covalent bonds, there is electron sharing. They share electrons. For example, I'm going to take HCl. Or to write example. Take HCl, for example. We have hydrogen. The hydrogen has an electron. I'm going to put it with the X. Here. And they have Cl. It has 7 in the outer shell, in the valence shell. And they will say, okay, you want to be stable. I want to be stable. The hydrogen want to be stable, to have 2 electrons to be like helium. Chlorine want to have 8 electrons to be like the closest gas, noble gas. So they say we are okay. But this sharing, is the sharing fair? This is the question. Is the sharing fair? What does it mean? Does the 2 electrons, the pair, passes 50% times with chlorine, 50% times with hydrogen, or there is here, or it is not? Okay, so it turned out that it is not. Okay, so the pair of electrons will be with most of the time will be with the one that most electronegative. Electronegativity, it is electronegativity. We saw it in grade in grade 11. What is electronegativity? It is the capacity to attract the electrons. So electronegativity, I'm going to write it here. It depends. So is the sharing fair? It depends of the electronegativity. The electronegativity of the atoms. What does it mean? Which one attracts more the electrons? Electronegativity is what? I'm going to give you the definition again. Going to be here. The electronegativity definition. The electronegativity is the capacity to attract the electrons of other atom. This is the electronegativity. But how we will know? We have a table. By experience, we determined the electronegativity, and now we know the electronegativity of each atom. This is a table with the electronegativity on it. For example, hydrogen has a power with 2.2. Lithium has a power with 1. Beryllium 1.5. Sodium has 0.9. Magnesium 1.2. You will see that the non-metals have a big electronegativity because they attract electrons. They want to have more electrons because they are closest to the noble gases. But the metals, we're going to see that they have less, because metals intend always to give up their electrons, to lose the electrons. So, for example, I see the hydrogen, it is non-metal, its electronegativity 2.2. The ones that will interest us, the carbon, for example, 2.5. The oxygen, it is very important, 3.4. The chlorine, 3.1. And you see here. So, with these numbers, we can say if the molecule is polar or not. For example, I'm going to go now to my example. HCl. Is HCl is fair or not? What I have to do? to take the electronegativity. What is the electronegativity for hydrogen? 2. This is its power to attract electrons. What is the electronegativity for chlorine? Its electronegativity is 3.1. We will have to make a difference. Delta En, the difference of electronegativity. So I'm going to put 3.1 minus 2.2. It gives me what? 3.1 minus 2.2. It gives me, I'm going to go to my calculator. I don't want to lose minutes. 3.1 minus 2.2. It gives me 0.9. So 0.9 is bigger than 0.4. So the bonding is polar. HCl is polar. Why? Because the difference of electronegativity is bigger than 0.4. Okay, what does it mean? If the electronegativity is less or equal to 0.4, it is not. For example, one hold with 51, the other one 51%, 94%. There is no difference here. So this is how we know the polarity of the bonding. We're going to take another example. For example, I have how we will write them. Since HCl is polar, what does it mean? Which one has more electronegative? Chlorine. So the chlorine will attract more the electrons. So it seems that chlorine is little bit negative. Why? Because he has electrons. He has an extra electron. That's why we put a symbol like what? We call it delta minus. This symbol here, it is delta. We call it delta. We put a delta plus. We say that the chlorine here, it is slightly negative. This one, we call it delta. Slightly negative. And the hydrogen, because he loses his electron, he share it, but not fairly. He will seems little bit positive. We'll write it here, delta plus. Delta plus, like this one here. And we're going to put like an arrow here, like that, to say that the electrons are attracted to chlorine, like that. And we call this one a dipole. A dipole. It is a dipole. This one here, we call it a dipole. I think we saw that in grade 11 in chemistry. Yeah, this is the revision. Roughly, it is a revision. We call this one, it is a dipole. I'm going to take another example now. I'm going to example 2. Which one I'm going to take? I'm going to take CO, carbon and oxygen, CO. So is this, for example, I have C and O here. Is this bonding polar or not? What I have to do? Again, the electronegativity. We're going to compare the electronegativity. Which one it is attracting more than others? Carbon, it is 2.5. Its electronegativity, it is here. Oxygen, its electronegativity 3.4. Delta electronegativity, I have to make the difference. 3.4 minus 2.5. 2.5. Again, it gives me 0.9. But 0.9, it is bigger than 0.4. So what does it mean? This bonding, it is polar. CO is polar. It has a dipole. Is polar. So what is the polar is? The more electronegative, it is the oxygen. So I have delta minus here. This one, it is less electronegative, so it will be delta plus. And I will have a dipole like that. This dipole here, so I have a dipole. Let's take another example. Let's take, for example, what I have, NaCl, for example. Sodium with chlorine. So this bonding here, is it polar or not? We're going to write it here, NaCl. Again, What is the electronegativity of sodium? 0.9, as I see here. What is the electronegativity of the chlorine? Chlorine, it is 3.1. The difference between them, it will be 3.1 minus 0.9. It gives me what? 2.2. This one, it is bigger than 1.7. So this one, it is polar. It is more than polar. It is ionic. It is ionic. When the bonding, when the electronegativity is bigger than 1.7, the bonding is ionic. Ionic. It is bigger than ionic. Yeah, this ionic. And now we have a rule. We have a rule. How we know the polar or not polar? We have a rule, and we are going to put this here. The difference of electronegativity will tell us what's happening. So I'm going to here to put it here. It is a scale of electronegativity. It is here. Go put it here. I will have here 0.4. I will have here 1.7. If the delta electronegativity here, I'm representing here the delta electronegativity. If the delta electronegativity is bigger than 1.7, it is ionic. What does it mean, ionic? Delta difference, it is bigger than 1.7. If I am here, it is covalent polar. Covalent polar. If I am here, it is non-polar. Covalent non-polar. What does it mean, non-polar? Delta N less than 0.5, than 0.4, less or equal. Here, delta En is between. It is bigger than 0. It is between the two. Good. It is between the two. Go to write it here. Delta En bigger than 0.4, but less than 1.7. So we have a scale, and this scale will tell us what's happening. So we're going to do another example, and that's it. For example, I'm going to take, I'm going to stay here because I need the table. I'm going to take carbon with hydrogen. Okay, carbon with hydrogen, to take carbon with hydrogen. And is it polar or not? We do the math. The carbon, it is 2.5. The hydrogen, it is 2.2. What is the difference? 2.5 minus 2.2, it will give us 0.3. So this bonding here is no polar. It is slightly polar, slightly. It is slightly polar. So what we're going to do it, we're going to put like this one, CH, like that. And which one it is more electronegative? It is carbon. So I'm going to have minus delta here and plus delta here. I want to always to put the positive in my say H plus, delta plus here, carbon here. We're going to put an arrow, but the arrow must be small, like that, to say that it is not. If I put, for example, before I put with which one I use it, I don't remember. The ones that I use it, I put like that. Hydrogen and chlorine. I put like that. So the length of the arrow gives me the amount of polarity. Here the length, it is small, to say it is roughly not polar because it is too small. Yeah, this is how we represent them. This is the polarity. Now, yeah, that's it. Yeah, do the exercises and that's it. So we know now how we find the polarity of the bonding. Good. Bye.